Because I'm not really interested in having my mug up there on my videos. Huh, right? All I'm really interested in on my videos, as I am in class, is that you can see the pen strokes. And, you know, I'd had this conversation with someone about why I'm not up and around the room more. And I feel as a kid, I always found it annoying when my teachers were at the board, especially my really non-skinny teachers, and I couldn't see what they were trying to write because like either I'm in the people's way over here or the people's way over there. So I like this technology just the way it is. And I don't need you seeing me. I need you seeing the content that I'm presenting. So that's why my face is not up there. You with me, Kevin? I mean, does it make sense? Right on. That's what I'm saying. And I thought, gosh, this technology is marvelous. It's not that I have some affinity for this chair. It's just it makes sense. You'll find absolutely no difficulty today as long as you can follow some basic steps. Today's date is really cool. It's 2, 2, 2, 3. And tomorrow's is 2, 3, 2, 3. I know. That's neat. So this will be a several day endeavor. This isn't a one day kind of thing. And it's like the level at which we do them is probably a one day thing, but they start to get a little bit there's different flavors and complexities of them. So that's why it takes a few days. But we're going to call these logarithmic equations. Make sure I spelled that correctly. Solving logarithmic equations. So I won't insult your intelligence on the assignment with any questions like this. I will, however, insult your intelligence right now by just giving you a very sort of generic example of a logarithmic equation. This. So, I mean, really, I mean, if you don't, the key is to all of this is the water cycle, that conversion from logarithmic to exponential, that blue arrow diagram that I keep drawing. So we say this to the this equals this. And I'll try not to draw that on every single problem today because we have eight examples after this, but like this isn't a real example. This is just to show you kind of what you're up against. So there's really no math to do in a problem like this because if you understand that cycle, the conversion, then it solves itself. Like it really solves itself. I just write 4 to the third equals x. And as you know, solving an equation is the art of getting a variable by itself. And in a situation like this, you're like, are you pranking me or something? X is already by itself. I just got to do some math. What's 4 to the third? Exactly, 64. So like this equation, I don't even have to do anything. I just have to understand how to flip the conversion. And there's absolutely no work I need to do. So make sure you're really good. I can't stress this enough. I don't have any words powerful enough to express to you how important that the blue arrows are. That's what allows us to convert a logarithmic equation into an exponential equation that we can then solve. Okay. So what's going to change as we go through the lesson is first off, you'll see in this first example, the argument of the logarithm. I'm going to bring your memory back to about a week and a half or 2 weeks ago. That gold thing is called the argument of the log. So the first change we're going to make is that the argument of the log isn't just going to be a variable. It's going to look like this. It is. I think it's a good looking N. Does it not look like an N? Yeah. I could do X's. I mean, there's N's on my sheet. There's some K's, X's, whatever. If you don't know how to attack and do the conversion, then you're just out of luck. I mean, there's just literally, you got no shot. Like some math, you could give it to a sixth grader and they could be like, I may not have learned this, but I can, if you just don't know the conversion, there's nothing to do. So let's flip the conversion on this, embrace the cycle diagram. We say this to the this equals this, right? And if you want to stop writing the 5 to the second, whatever, I would encourage you to just bypass that. So 5 to the second power is 25. So we just write 25 equals what? 4n. And it goes immediately from a high school level math problem to like a seventh grade. Like it happens just like that. And now you go, really? You want me to solve this? So I divide both sides by 4 and I get n equals 25 fourths. Presto, done. Of course, that's not it. But for that problem, that's it, right? But again, you see what I mean? Like if we don't know how to do the conversion, we got nothing. But the conversion is everything. You flip it over to the other type of equation, and then you solve whatever's left. All right, let's do another one. This first column of the first three I have, they're pretty lackluster, not very exciting. So we have log base 7 of the quantity 3x plus 10 equals 0. It's like a foreign language, right? Like who knows what x is, but we can flip it. So do your little water cycle diagram. What is 7 to the power of 0? 1. Right. So my equation in its other form would say 1 equals what? Good job. So just like that, the conversion happens and it immediately morphs into a question that you wouldn't even struggle with in like pre-algebra. What are we going to do next? Subtract the 10, giving you 3x equals -9. And you get x equals -3. Done. Right? So these ones we're just kind of going in, hitting it with the cycle conversion, and then solving the little rinker dinker that happens. All right, let's do one more little baby warm up. Huh? These are my examples. Yeah, these are the. Mhm. So after this, I'll be able to say 3 down, 5 to go. And the last 5 are a little harder, but as you guys have been proving, you're not freaked out by this stuff. You just follow steps well, you're learning well. So you're not worried about this. You're not going to have any issues. So do your little conversion. What would the next equation say? Perfecto. I mean, it's amazing how quick it happens. And you're like, wow, you went from that to that. And then we just add 1 to both sides. What's k? Done. Right. So that's the general gist. Basically, remember the vibe and kind of the flow of these problems and how easy this is. And just as we get into these next ones now, just think about, I want them all to be like that. All right. So you remember like the battle cry a long time ago was like, get the absolute value by itself. It always seems like there was this get the whatever by itself, get the radical by itself, get the whatever. That seems to be a thing. We're back to that thing now. So we really today, like right now, need to get it stuck in our brains, like sponge it in there. We want to get the log by itself. Repeat those words again and again and again and again and again. That'll be really now what separates us from we get it or we don't get it. Get the log by itself. Because in all these problems, the log has already been by itself. But now I'm going to switch it up and it's not going to be that way anymore. So let's say we have -4 plus 3 times the log base 8 of 4x equals -1. It looks like a jump up in difficulty. It's not. It's really just, it's who's willing to listen and repeat those words. Get the log by itself. And by the way, the 3 is not part of the log, so he needs to go also. This equation, if you have a decent perspective, if you see math the right way, you would agree that this equation in how we should approach it is not an ounce different than this equation. Like you stare at that as long as you want. And I would hope at some point that you would agree that if I just replace the log with the letter M, you see on the right written in green an equation that you could have solved back in like 7th grade, right? So we would add 4 to both sides. We would divide by 3, right? So let's remember as we go through this that just because it's a logarithm problem, we don't abandon our fundamentals. If my math teacher tells me to get something by itself, I know how to do that. I can do that. But don't mess with the log. Leave it alone and just get all the stuff that's with it away. So in the white equation, let's add 4 to both sides first. This -4 has to go. And I rarely will show this much work. Like more than halfway done with algebra 2. We don't need to be showing +4 on both sides, for God's sake. But for now, that's what I'm doing. And so what I'm left with now is 3 log base 8 of 4x equals 3. I'm going to pause this and answer the phone real quick. Good to this point? So if I, now I'm thinking get the log by itself, what do I do? Divide by 3. Don't even think about the water cycle diagram yet. This is really where we make or break the entire next day or two, is get it, finish the job by itself. If I divide both sides by 3, I wind up with log base 8 of 4x equals 3 divided by 3, also known as 1, right? And at this point, now that the log is by itself, you realize this is no different than those little fluffy puffy introductory examples that we did. What would the next equation say now? Right, do the water cycle diagram. 8 to the 1 equals 4x. So 8 is equal to 4x. Divide both sides by 4. X is equal to 2. Jackpot, done. And it's, you don't want to probably do this because you're not a dork like me, but it's kind of fun sometimes to go back and actually check your answer. Like if you say x is 2, you could seriously go all the way back to this very beginning problem and change x into 2 and just watch the magic happen. Most people aren't interested in this, but if you put 2 right there, check it out. What is right here in this blue box? What's 4 times 2? What's log base 8 of 8? 1. What's 3 times 1? What's -4 plus 3? I'll be darned. That's kind of neat. So it's okay to be a dork. Go back and check your answers and just kind of verify that they're legit. You know, with Delta, it does that for you, but on a worksheet, it's kind of nice to do anyways. How about this one? 2 minus 8 log base 5 of 3x equals 2. What are we going to do first? Get the log by itself, right? So a little more specific. Subtract the 2, we're going to get -8 logs of blah, blah, blah equals 0. And then we have to divide by 8. So we get the log officially now by itself. Log base 5 of 3x equals, yeah, we divide by -8. You're going to get 0 no matter what you divide by, right? 0 divided by anything. And then do your cycle. What's 5 to the 0 power? So we get 1 equals 3x. Divide by 3, x equals jackpot. And again, it's not a crime to go back and check it, plug in 1/3, do the math, and you're like, neat, it works, right? I did not put any on here that have extraneous solutions. So sometimes you will find with certain later on logarithmic equations that you remember how we go back and check our answers and one of them like wouldn't work and we'd cross it out. That can happen. It just won't happen today, for the record. Okay. But it will be coming down the pike at a later date. So let's go again. 3 log base 4 of the quantity 5x minus 9 minus 10 equals -1. We're not scared. No. Dividing by 3 is fundamentally bunk, right? Remember, when you solve an equation, don't abandon your fundamentals, right? Totally. Maddie keeps saying add 10, add 10. We got to get that -10 gone. So if you add 10 first, you're left with 3 of the logs is equal to +9. And then divide by 3, and you get log of blah, blah, blah. We don't care what the log is at this point in time. It's just like a physical object that we're toting around is equal to 3. And this is where we cycle it out, convert it. What's 4 to the 3rd? So we get 64 equals 5x minus 9. And then it's just instantly transformed into a little baby kitty problem. Add 9 to both sides. What do you get? 73 equals 5x. Divide by 5. What do you get? Nice. That's it. Okay. Guys feeling good? I just want to caution you. I feel like you got this. It's pretty easy. I'll bypass some examples, but I want you to know that you are going to get some answers like this that you might look at. If you get like 1,298 over 31, that's okay. Like it's just going to sometimes happen. The nature of the beast is what it is. And if you're really motivated, um, you can always plug them back in. Check. And if you want to know if it's legit, check it. Put it back in. It's okay.